Coming to DARPA is like grabbing the nose cone of a rocket and holding on for dear life.
DARPA is a place where if you don't invent the internet, you only get a B.
A DARPA program manager quite literally invents tomorrow.
Coming to work every day and being humbled by that.
DARPA is not one person or one place. It's a collection of people that are excited about moving technology forward.
Hello, and welcome to Voices from DARPA. I'm Stacy Wurzba, and I'll be your host.
10, 9, 8, 7.
Imagine
5,
you're going to space.
3, 2, 1. Engines full power. And liftoff of CRS-27. Go Falcon, go Dragon.
Falcon 9 soars off the launch pad. Dragon now on its way to the International Space Station with important new science experiments and crew supplies.
There's a long list of items and supplies you'll definitely need. But there's an even longer list of things you might need, depending on how your mission progresses. This includes unforeseen needs like fuel for unexpected maneuvering, replacement parts or tools, and a wide range of other products that could be useful but may not be utilized. The current paradigm in space is to pack everything you might possibly need, but this approach is complex and logistically burdensome. Imagine, instead, that you pack only fermentation equipment, feedstocks, and a freezer full of microbes that each convert the feedstock into a different useful molecule, material, or product, so you have everything you might need and can produce it on demand. Or, what if you could enable a new paradigm, where future space structures that are much too large to launch on a rocket are built off Earth using materials and designs optimized for the space environment? Today, I'll be speaking with Dr. Andy Detor, Program Manager in DARPA's Defense Sciences Office, as well as Dr. Ann Cheever, Program Manager in the Biological Technologies Office. Dr. Detor runs the Novel Orbital Moon Manufacturing Materials and Mass Efficient Design, or Nomad program, and Dr. Cheever heads up the Biomanufacturing Survival, Utility, and Reliability Beyond Earth, or BSURE program. While neither program is conducting manufacturing in space, both are supporting proof-of-concept studies to determine if it might be feasible in the future. Here's Dr. Cheever.
The Biomanufacturing Survival, Utility, Reliability Beyond Earth program aims to answer fundamental questions about the feasibility of microbial production in space. And so we're looking at different aspects of how microbes could grow in space conditions. And those would be utilization of alternative feedstocks or different things that you could feed them that you could find in space. Or we're looking at different gravity levels, specifically low gravity. Does that affect how microbes grow and produce a product? And then how about radiation? So galactic cosmic radiation, does that affect the bioproduction of microbes in space? Currently, there is no space-based manufacturing capability. So everything that we need in space, all resources, all equipment, anything needed for a given mission has to be manufactured on Earth and then launched into space. There are some very interesting and challenging supply chain questions and launch constraints. It's expensive to launch large amounts, large mass quantities to space, and biomanufacturing offers a novel alternative manufacturing paradigm for that far forward location like space, that ability to have on-demand production of a product when you need it and where you need it.
While the BSURE program focuses on the microscopic, the Nomad program opens the aperture a little wider. Here's Dr. Detor.
Today, we are limited in the size, both the mass and the volume, that we can launch from Earth. The Nomad program is really about fundamental materials and manufacturing technology and enabling the construction of large structures in orbit. It's not something that anyone's looking at yet too closely. And so NASA has an amazing roadmap with their Artemis program, with their LSIC consortium, landing on the moon and then going to Mars, but not looking at large structures in space to enable things like solar power, sensors, island depots, things like that. So things that are 3 to 10 times bigger than what we can reasonably launch from Earth today. The reason that is important is that a lot of things get better when they get bigger. Things like solar farms. The more solar cells you can put out in terms of area, the more power you can harvest. or optical mirrors. The larger the mirror, the better the signal-to-noise ratio if you're making a telescope. And so Nomad's looking to totally disrupt how we do things today by enabling manufacturing of materials and structures in orbit.
In order to disrupt, first you need to understand how things work today. We asked Dr. Detor about his journey to DARPA and what inspired his love of engineering.
My dad's an engineer. Always, as I was a kid, following him around, fixing things around the house, fixing cars, making things in the workshop. And so I was always just very hands-on as a kid. And that, I think, in large part led to my pursuit of an engineering degree and trying to understand how things work by taking them apart and putting them back together. It wasn't until midway through my undergraduate that I discovered materials science as a field. Material science is all about understanding why materials behave the way they do. For example, when you take a paperclip, and we've all done this experiment where you bend the paperclip and maybe you're nervous, so you're doing something else and you keep bending it, and eventually it breaks. Material science can explain exactly why that happens down to the atomic scale and the mechanisms that are responsible for that, what we call fatigue failure of your paperclip. So it's just one example. And it doesn't just apply to metals, all material classes, polymers, ceramics, metals, composites, trying to link how those materials are made to their micro or nano scale structure, and ultimately how that dictates their properties that are useful in service.
DARPA program managers aren't just inspired by the world around them. Sometimes it's something a little more fantastical that ignites a spark of innovation.
I'm a big science fiction nerd. That's all I read when I can read, when I have time to read. I think that in my collaborations and conversations about this program, the movie The Martian comes up a lot.
I got to figure out a way to grow 3 years' worth of food here on a planet where nothing grows.
So being able to sustain life on inhospitable planets or places that aren't Earth, and how do you do that? How do you have the infrastructure and the ability to do that comes up a lot. And I think biomanufacturing can play a real role in that in terms of both sustainability and just sort of in situ, in place, not having to rely on that umbilical cord of supply chain from Earth.
Like many DARPA programs, there are a number of elements for both Be Sure and Nomad. So let's break each of them down individually. For Be Sure, there are 3 research tracks: alternative feedstock, radiation, and low gravity.
For the alternative feedstock track, we have Washington University at St. Louis, who is looking at different feedstocks or different things that you can feed microbes that you can find in space so that you don't have to launch sugar. On Earth, microbes eat sugar to produce something. We don't want to have to launch sugar. It's super heavy and it's just inefficient. So in space, there are things like CO2 or waste streams, human waste, plastic waste that we could utilize to feed our microbes instead of sugar. As part of that track, we have Space Tango, who is incorporating the biological data from this track and other data sources to understand and model the feasibility of biomanufacturing in space. The radiation track team at the University of Texas at Austin is looking at unique radiation sources that you'll only find in space, such as galactic cosmic radiation. That's something we don't experience here on Earth. Our atmosphere shields us from all of that GCR. However, when you're in space, you're outside the atmosphere, you're outside that protective shield, and so microbes will be exposed to varying levels of GCR. To understand how that may affect the bioproduction that those microbes are engineered to do. So they will test them to varying amounts of GCR to understand how that affects their growth and their bioproduction, and then engineer them to be optimized to produce in those conditions. An interesting question is also whether or not it's worth engineering or is it worth shielding? So it's a cost-benefit analysis of if you engineer these organisms, do you lose bioproduction, or is it cheaper to just add more shielding to a biomanufacturing capability? The low gravity track team from the University of Florida, they have been able to prepare samples and then launch them to the ISS, the International Space Station, National Lab, to understand how low gravity affects their bioproduction.
We caught up with Hannah Roberts, a PhD student at the University of Florida, serving on the Be Sure team, just before their experiment was sent up to the ISS National Laboratory. That was the rocket launch call you heard at the beginning of this episode.
Our team's goal is engineering a whole range of microbes from bacteria to yeast to produce a whole bunch of important compounds for biomanufacturing in space. So that instead of having to pack all of your stuff from home, whether that be vitamins to fuels to bioplastics, you could produce it in space there. And the goal of this specific mission is to send these organisms to the International Space Station, where the data from there will be compared to some data of Earth equivalents of simulating microgravity as well as regular Earth gravity levels to prove if biomanufacturing in space is possible.
And so they'll analyze the results of this experiment. It is back on Earth now. So they're looking at those microbes to understand what the effects were. And they'll use that data to then optimize the production. So they'll engineer those microbes to produce a product better than they initially did. So this was their baseline experiment. They'll optimize them and then they'll retest them later on. So one of the things that I've been really excited by and surprised by is the ability and the infrastructure that's in place to allow science to get to the ISS National Lab. And so in the Be Sure program, we've worked really hard to find partners and performers that can assemble experiments and get them up there. And we predict that we will have 3 experiments going up to the ISS National Lab within a year's time frame as part of this program.
Again, that was the Be Sure program. Let's move back to the Nomad program and Dr. Detor.
Nomad overall is a 4.5-year program, and it's divided into 3 18-month phases. We are just about at the end of the first phase, and so we're getting into the middle phase 2. In phase 2, the goal is to demonstrate on Earth a proof of concept for the performer technologies. So we will not be launching anything into space in phase 2, but really just trying to de-risk the technologies that are being developed so that in phase 3, we can select a couple performers to do in-orbit demonstrations. So one of our performers, the approach that they're taking is if you've ever driven by a used car store and you've seen those inflatable, wacky flailing arm guys out front.
Wacky waving inflatable arm flailing tube man. Wacky waving inflatable arm flailing tube man. Wacky waving inflatable arm flailing tube man.
They are trying to do something similar to that in space. They're developing a method where they encase metal sheets in a hydride film that they can then expand in space with the application of heat. So heat causes the hydride material to decompose, producing hydrogen gas, causing pressure, and they're inflating structures in space. And that's one way to achieve stiffness and therefore achieve large structures. Another performer is developing a process to extrude carbon fiber composites in orbit so that they launch just the resin and the carbon fiber reinforcement, and they developed a process to actually build long structures out of carbon fiber in orbit to ultimately be assembled into larger structures. The end game for the program is to do a demonstration in orbit. And so in the final phase of the program, which will be a couple years from now, we do plan to launch an experiment to orbit where we demonstrate some of the performer technologies, but it will not be on the surface of the moon.
So tell us, what's next for the program? Where do we go from here, and what do we hope to achieve?
The results of the Be Sure program will help us understand whether biomanufacturing is a path towards alternative manufacturing, but we're not there yet. So following this program, we will have organisms that can produce in space conditions, but we still need the hardware, we still need the infrastructure, we still need to understand how that ecosystem looks for manufacturing and supply chain logistics in space. We've had some great collaborations with NASA. There are missions that align with the DoD in terms of sustainability in space and manufacturing in space, supply chain logistics. We're working with Space Force to understand their needs and to work towards transition in the future where they could use biomanufacturing as an alternative manufacturing paradigm for supply chain logistics.
We've had discussions and are collaborating very closely with folks at NASA as well as Space Force. And really the technology being developed on Nomad is very fundamental materials in manufacturing. And so the idea is to hopefully transition some of the methods that are being developed, the designs that are being developed to NASA or Space Force for them to pick up and run with in their applications. Another potential transition of the Nomad technology is to commercial space companies. So getting access to orbit is becoming much cheaper and more frequent. And so that makes access to space so much more accessible and affordable. And so we hope that the technologies developed on Nomad could be used for cislunar and commercial activities as well.
The short tenure and continual rotation of DARPA program managers, office directors, and deputies are probably the single most distinctive features of DARPA's culture and the most important contributors to continuing innovation. Those people generally hold their jobs for only 3 or 4 years. The end of their time at DARPA is always in view. Their expiration date is printed prominently on their ID badges, a constant reminder to them and their colleagues that time to accomplish important work is limited. In addition to fostering that sense of urgency, limited tenure means that new people are always being hired, bringing new ideas and their passion for those ideas with them.
I was introduced to DARPA as a principal investigator on a DARPA project while I was a scientist at GE. And one thing I very quickly learned while working on a DARPA project as a performer in industry is you have to think completely differently. Working on traditional industrial research and development projects, you have this mindset of it needs to work. This has to be possible, and it has to have an impact on the bottom line of the company in several years. At DARPA, you're motivated to try to do the impossible. And so DARPA programs are different in that failure is an option. We are trying to do really hard things, and it's okay if we fail. That means we're trying to do something new. And that excited me really so much that it's a big reason why I'm now here as a program manager.
I came to DARPA as a CETA a long time ago, so I was a scientific and engineering technical advisor. Every program manager here at DARPA has a team of awesome PhDs that help them develop and run their programs. And so I did that for a long time, and I was really inspired by the mission of DARPA and by the Biological Technologies Office. And so I went away for a little while and really missed it. And then the opportunity came up to come back as a program manager. And so I jumped at that and I came back, and I've been working on a synthetic biology portfolio ever since. BSure is one of my programs. It's one of my first programs, actually. I've actually been really inspired to develop programs that can help the warfighter, especially looking towards the future and down the road. That's something that I really care about.
Honestly, when I came to DARPA, I did not have any intention of running a program to do with space technology. It's not really my background area. And honestly, I was a little skeptical of inheriting this program because it's not an area I know much about. However, having been here for just 6 months, I've been fascinated by the technology that's being developed and the future in this area. And so I've just been learning as fast as I can about the challenges specific to space. And one of the nice things about materials science is that it's such a broad discipline that the things that I've learned and understood about manufacturing here on Earth, a lot of that applies to space. And so I'm finding a comfort zone there. DARPA's just a fascinating place, and I've absolutely enjoyed it so far. And I'm glad that I have several more years to go in my tenure. And, one of the things I'm finding as a program manager, DARPA's all about good ideas. And program managers don't just come up with good ideas in a vacuum. It's about the performers. It's about professors, folks in companies and national labs. So one of the favorite things about my job now is just talking to people and hearing their ideas and their thoughts, whether they turn into a DARPA program or not. And so for everybody listening, if you have a good idea, something that's really revolutionary, groundbreaking, DARPA hard, reach out to a PM because we're all ears and that's what we're here for.
Thank you for listening to this Voices from DARPA podcast. For more information about either the Nomad or BSure programs, please visit darpa.mil. Thanks for joining us, and special thanks to Tom Shortridge for producing this episode and Eric Butterbaugh for his assistance. Lastly, I'd like to share my gratitude to the BSure team for inviting me to witness their inaugural experiment launch to the ISS. Definitely a bucket list item for me.